Hey, what's up? It's Jake from Nimbus DevOps, and I was going to talk to you now about some performance considerations when coding. So we've used map, zip, filter, and chose to go with comprehension or a generator, and even look at for loops and logic to apply a running parameter. And it's not always simple, but you have to figure out what the best option is, right? So besides readability, though, there's also the performance consideration. So when it comes to performance, there's usually two factors that play a major role. Okay, space, and time. Okay, space is the size of memory that a data structure is going to take up. And the best way to choose is to ask yourself if you really need a list or a tuple, or whether a simple generator function would work instead. If the answer is yes to the latter, go with a generator because it'll save a lot of space. And the same goes for functions. If you don't actually need them to return a simple list or a tuple, then you can transform them into a generator function as well. But sometimes you will have to use lists or tuples. So, like if you have an algorithm that scans sequences using multiple pointers, then maybe they run over the sequence more than once. And a generator function or a generic expression can be iterated over only once and then it's exhausted. So in that situation, it really wouldn't be the right choice. So although it is less performant, um, it does the generator does not actually give you the functionality you need to solve that problem. The time is a little bit more complicated than space though, because it depends on more variables. So it's not possible to state that like, oh, this is always faster than this with absolute certainty for every single case. Based on tests run on Python today, on average, map exhibits performance similar to comprehensions and generator expressions, and while for loops are consistently slower. So the map is definitely going to be, like on average, like I said, faster. So to appreciate this reasoning, we'll take a look at how Python works a little bit outside the scope of what we're going to be doing as developers. But if you're a software engineer, this is definitely something I could see you getting into. So let's say that map and comprehension run C language speed with an interpreter, while Python for loop is run as a Python bytecode with a Python virtual machine, which is usually slower. So how can we do a small little exercise to figure out whether these claims are accurate? Well, let's try to write a little piece of code and we'll use the time module to see if we can calculate the elapsed time of a program. So we'll just say from time import time, and mx is going to be 5,000 on a new line. And then let's say t equals time. Go. All right. And then we're going to make a for loop equals this list and say for a in range 1 to whatever our max value is. For b in range a and then mx, we're going to do floop dot append div mod a b. And then at the end, we're just going to say print for loop. Let's see, let me get inside the string here. For loop, and then we'll make a set colon dot for f, and then s dot format, and then we'll do our time minus whatever t was. And that should be our elapsed time, like that. Like that. There we go. Okay, so then I can say t equals time, and that'll be the start time for list comprehension, and we'll do comprehension equals, and then an empty list, not compile, an empty list. There we go. We'll say div mod ab for a in range 1 through mx, for b in range a mx, and then we'll close this list and print list oops, make this a string. Let's print out this comprehension And then we'll make a set colon dot for f s and dot format time minus t, like that. Then I can take it a step further and say t equals time, and we can start a time for generator expression and say gener equals a list, and then rounded div mod a b for a in range 1 max, for b in range a max, like that. That should work. And we've created 3 lists. We've got a for loop, we've got a generator, or a comprehension, and a generator. And so let's run this code and see what happens. So let's type Python performance. I messed something up. This guy, line 12, print for loop. Oh, I gotta close this. Silly me. There we go. Okay, try it again. Ah, I messed this one up. What did I miss? This one should be closed and then an S. One last try. Debugging your own code. Okay, so we've got this for loop. Did I print out the generator expression? No, I did not. Okay, let's do that really quick. All right, so let's print generator expression, and then we'll make this set will be colon dot for, close it this time, S apostrophe dot format time minus T. Save. Okay, clear, run it. Hopefully that works now. Okay, so our for loop took 1.7 and change seconds. The list comprehension took 1.08 seconds, and the generator was 1.28 seconds. So what can we derive from this? The list comprehension is less time taken than the for loop, and the generator is less as well. The difference in time between the list and the generator is really not that significant. And if you rerun this example a few times, you'll probably be able to see the generator expression takes less time than the list. So let's run it a couple more times. We got 1.8, 1.0, 1.2. So the generator is still a little slower than list comprehension. Generator is still a little bit slower. And it just depends on what you're iterating over to, right? But this is pretty consistent. An interesting result to notice, though, is that within the body of the for loop, we're appending data to the list. It implies that Python does work behind the scenes on resizing it every now and then, and it allocates space for items to be appended. Creating lists of zeros, things like that, and filling it up with results could have sped up the for loop, but it's actually not true. And you can check that. You just need like a mx times mx minus 1 mod to be pre-allocated. If you pre-allocate some of this stuff, it actually does not make it faster. So, apart from little case-by-case differences, it's pretty clear the for loop option is always going to be your slowest one. And there may be reasons why you still want to use that, though. And I'll go over that in another video. But just in general, now that we're getting over different ways to solve problems, just keep in mind that if you are considering using a for loop, you need to have a reason to do that because you are intentionally choosing something that is slower than something like list comprehension or a generator. So I hope that helps. If you have questions, let me know. And if not, then happy coding.